Hello, my name is Pappy Bedard and welcome to another one of my tutorials. Cinema 4D gives us all the tools we need to create beautiful and stunningly complex geometry with the use of formulas. In this tutorial, I'll show you the method I use to find formulas to use and how I explore variations in those formulas. Today I'll show you how to make this effect by animating a formula spline by using the standard renderer and no plugins. I'll break this presentation into a few different sections. First, I'll go over the formula object properties so that we understand them. Then I'll show you how to find a formula and use Xpresso to explore variations in the formula's parameters. And then we will create this animation. Finally, I'll show other examples of formulas that we can explore and study. So first, let's take a quick look at what's behind this animation. So this is one spline that's created with this formula you see here on the right. Now, let me hit play, and you can see that the spline is animating by changing these formulas. Actually, if I single step through each frame, you could see that every frame those formulas change. So I will show you how I do that. So before we get into creating this project, I want to talk about the spline, the formula spline object, and what its parameters actually mean. So we'll start with a new project here. And we'll add a formula spline. So by default, it comes with some parameters already filled in, and it looks like it's creating a sine wave from minus 100 to 100. So how does it do that? Well, look at these parameters. The first three are functions: the x of t, the y of t, and the z of t, or formulas, or equations, however you want to call them. Following that, we have T-min and T-max, which is a range of numbers. And samples is how many samples between those two numbers we want to take. So in this case, it's going to take 20 points between -1 and 1, or 20 numbers, and plug them into these formulas wherever the t is. So in other words, the very first point will be this 100 times t, and the first point is -1. The middle point would be 0, halfway between 0 and between -1 and 1. So it would be 100 times 0. And the last point for xt will be 100 times 1. So that means the x ranges from -1 to 1. Now, what happens to the y? Well, that's a little different. Here they're multiplying 100 times the sine of t times pi. So all trig functions in Cinema 4D use radians, not degrees, as their parameter. So here they've multiplied t, -1 all the way to 1 in 20 steps, by pi. And all that's doing is, pi is actually 180 degrees. So it goes from -180 degrees to 1. Pi radians is 180. So in 20 steps, it creates that. Now, if this still remains parametric, I could change the number of steps here. So watch what happens if I set only 3 steps. 1, 2, 3. It's not very round anymore. 4 steps, 5, 6, 7. So default of 20 is fairly close, but you can still see a little bit of straight lines in there. Now you can smooth that out by clicking on cubic interpolation, or you can vastly increase the number of points. Let me go back to the default by right-clicking on these double arrows. And let me just show you, if I hit C to make that editable, it turns it into an actual spline. I'll go to point mode, and you can see those 20 points here. Actually, there's 21. It starts with 1, so there's actually 20 segments. Now I'm going to back up out of this to go back to the parametric version. So this samples is how many segments that the spline is going to have. The plane is pretty obvious, just like a lot of other controls. XY is the XY plane, YZ is the YZ plane, and ZY, XZ is the XZ plane. So we'll leave it at the default. Reverse just reverses the points on the spline, so start to end, end to start. And the rest of the controls are similar to every other spline, which I won't get into right now. So that's the basics of what these things are. So how would we explore variations in this particular formula? Well, there's not a lot to play with. You could change this 100 to, say, 10. So now it only goes up 10 times. By the way, the reason they're multiplying this by 100, let's get rid of this altogether, no hundreds at all, is because the result of t is -1 to 1. It's very small. I can zoom in on it. So it's exactly the same shape, but much smaller, because sine functions return a value between 1 and 0 and -1. And t, because of the way this is set up, is also between -1 and 1. By the way, if I change this to 2 or 3, you can see what's happening here is it's just giving us more range of samples. But now I stretched it too far. I don't have enough points. I only have 20 points, and I have 18 bumps. So I would need to increase this a lot. Let's just make it 2,000. In fact, for the most part, a couple 100,000 is good for playing around with. And then if you have really, really long splines, like that shape I showed you animating in the beginning, you need lots and lots of points. And in addition to that, cubic interpolation to smooth it out a little bit. So for most of these examples I'm going to show you, I'll probably leave it at 200,000 and cubic interpolation, depending on what I'm showing you. So we could extend that curve the other way by making it less than -1. Actually, you could say 10 to 19, and it starts at 10. Let's go to 20. You could see by the grid here, it's going from x10 to x20. So anyways, for the most part, they multiply this t number by a large number just because we want to make it, go back to multiply by 100. We want to make it big enough to work with. So now we're back to the original shape. I'll reset all these back to the way they were. So that's pretty much it for the interface. It's fairly simple. Now, every one of these has this little keyframe button, so we could keyframe any of these values. Like, for example, here I could hold down the Alt key, and you could see I'm increasing by 0.1 each time as I click these arrows. Well, you could animate that pretty easily. So you start at the beginning and set it to, well, let's just set it to 0. And we'll set a keyframe. And then we'll go to 150 and we'll set it to 10. And we'll zoom back out here and set another keyframe. Now if I hit play, you can see that I'm animating the creation of that spline. Now since I only have 20 samples, it gets a little funky at the end, so we could pump these up. And now when I play it, it looks a lot smoother. Now, the equations themselves also have buttons to keyframe them. But the thing is, how can you keyframe that? There won't be a smooth transition. To show you what I mean, if I keyframe here 100 times t, and then let's say at frame 30, I make it 200 times t. Well, it'll change to that, but it'll be abrupt. See, as soon as I'll single step through that. So here, I'm going one frame at a time. As soon as it hits frame 30, it changes to 200 times t. There's no smooth transition from 100 to 200. If you wanted to do that, one way would be every frame you type in a different number here from 100 to 200. Well, that's way too much work. So that's where a little bit of Xpresso comes in handy. And I'll talk about that next. So what I want to do here is set this up so that I can explore different parameters here. So right here we have 200. I'll set it back to 100. Let's say we want to make that an easily changeable parameter. And then here we have t times pi. I want to change this formula a little bit. Let's go from 0 to pi here. And then let's call this just t. Well, that's only half a sign. So let's make this pi times 2. You can just type in a formula right there and it'll do it. So we're going from 2, and then let's see, 100 times t. So there was a nice sine wave. And 100 times t is giving us 100 times 6, so it's 600 long. So, all right, let's play around with it. Let's also put another multiplier here, times 1, and t times 1 here. What happens if we multiply that by 2? Oh, it doubles the frequency. Times 3 triples the frequency. So that might be a cool parameter to have. I'm just going to leave it at 1 for now, which is the same as just times t. So I'm going to create some user data that we can use to change these formulas really easily. So I'm going to add, manage some user data. I'm going to add a group. Let's call it parameters. And then let's move this over. So what we want, let's call this an x multiplier, this 1 right here. So we're going to create, let's call it xm for x multiplier. And we want it to be a real number. And we want to default it to 1, but I don't care about giving it any maximum or minimum limits. So that's going to replace that 1. We could call this 100x size. So let's just create another one, call it xs. And we'll default that to 100. Let's put the size first. Then we'll call this one y size. We can make that the same, or I'm just going to change it to y size. So what I'm doing is I control clicked and dragged. So I copy that exact thing, so it's the same thing. And then we have the sine of t times 1. Well, let's call that the y multiplier. So I'm going to click on xm, hold down control, drag it down. So I've created a copy of it. We'll rename it to ym. And we'll default that one to 1. Okay. So if I hit OK, it creates a user data tab which shows those parameters we can use. So I'm going to hold Shift and open both these tabs at the same time. Now, first of all, I'm going to delete the animation I had done before. So I'll delete that track, and I'll delete this track, so we don't have any animation. Now, how do I get these parameters to control what these formulas are? Well, all it takes is a little bit of Xpresso. So I'm going to right click on formula and add a programming tag, Xpresso. That opens up this Xpresso editor. And we can drag the formula into there twice. And I'll show you why in a minute. In between these, I'm going to create a new node of Xpresso, and I'm going to create a Python node. Now don't get scared by this. This is just a tiny bit of Python node to change numbers into text. Let me go back to formula and explain what I mean. So down here under parameters, we've set these up as real numbers. So we can change these. We can right click on them and reset to default. But these are numbers. What this is a text string. So you can't plug a number into a text string. You kind of have to do a little bit of conversion. So that's what this Python node is for. It's not a lot of programming. So I'm going to start by deleting all these ports. We don't need these. I could have renamed the first two, but I'll this one I'll show you. This output, if you hover your mouse over it, it says that it's a real number. I don't need a real number over here. I need a string. So I'm going to delete this port. I'm going to add two ports, one for XT and one for YT. And they're both going to be strings. So I'm clicking on this little red square, and then I'm choosing the data type I want for the port. So here I'm going to right click on output 1. My system seems to be lagging because I'm recording it, I guess. I'm going to rename this to XT. And I'm going to right click on this one and rename it to YT. And over here, remember I dragged this formula object into here. I'm going to click on the red, and what I want to do is expose some ports. We created user data called XSize, X multiplier. I'm just going to put them in the same order. And then Y, whoops, Y size and Y multiplier. So I need ports for this Python node to accept those values. So I need to create some. So I'm going to click on the blue square. And what I need is 4 floats, which is the same as a real number. I'm going to create 4 floats. And I'm going to rename those. So I'll give it the same names. XS, XM, YS, come on, I'm right clicking here and it's not opening up the little menu. YM. Okay, now I can link these across. So this is feeding the numbers that we have on our interface into this little Python node. Once they're in there, we can use them. And so I'm going to down here open the Python editor so we can get a better look at the code I'll be typing in. Again, it's not a lot of code, but and then click back on the formula so I can take a look at these. So I'm going to copy this and paste it in here. That's what we want xt to become, or something like that. And I'm going to copy this, and I'm going to create a new line here that says yt equals that. But I can't do that because xt and yt are strings. By the way, any variable output on the right-hand side of the Python node, you have to define as a global variable. And I see yt is missing. I'm going to add that there. So this has to be a text string like this, in quotes. And so does this one. But of course, I don't want that hardwired text to be the values that I plug into the formula. I want to replace this 1 right here with xm, the x multiplier. So I'm going to say, now I just can't put xm here. It recognizes the value xm, but it won't convert it to a string. I have to do that manually with an str function. So this will take this text, 100 times t times, and add xm converted to a string to it. Now I've got to do the same thing to this 100. So I'll take it out of the text here, and I got to put a string of, that was x size, xs. So I'm taking the string of xs, adding this times t times in the middle, and then the string of xm. I could do something very similar here. I'll just copy this, paste it here. This time it's ys. Get rid of this 100. And on this side, I've got t times 1. Well, I got to put this in here, or something like this. Get rid of the 1. I'm going to type quote, quote, back, plus, plus, and then stick that in the middle there, and put ym. So this now is all I need in here. So that's the only Python we need to play around with this. But I have to plug these values into the original formula. So here I need to go to Object Properties, xt. So xt gets plugged into xt, and yt gets plugged into yt. All right, now we can close these out. Now, if we go back to this formula, these should actually, yeah, see now as I change the value of x size, it's changing that. The x multiplier, whoa, that has quite a big effect. I'll hold down the Alt key. So you could see that that's also working. Now the y will be more interesting. So y changes the size in the y, and ym, this is the thing that changes the frequency. Look at that. That's pretty cool. So now that we have these user values, user data values, these are also keyframeable. So now we can keyframe these. So going back to that, by the way, if I can select all of them. See, they turn yellowish, and then right click and reset to default, and it'll reset them all to the default, but it won't change anything up here. Or I could do something like this. Click on XS, hold down the control key, click on YS, hold down the control key. Now whenever I change one, the other one changes to the same value. That's kind of, it's going to come in useful later. So I'm going to reset those back to default. So remember we said, how do we go from 100 to 200? Well, let's do that. We'll start at 0 here and set a keyframe for XS as 100. And then at frame 30, we'll change this to 200 and keyframe it again. Now watch what happens. It gradually goes from 100 to 200. Let me just show you a loop at 30 frames just to show you how that looks. So it's just going to keep repeating that. Well, look what's happening at this formula here. That equation is changing every frame, and it's because we've only got 2 keyframes on this value. So that's how you can animate and play around with variations on a formula. Now, depending on the formula we put in here, we're just playing with a simple sine. You could have multiple parameters. Oh, I changed that to 13. Okay. Well, this is a good place to move on. So I hope by this point you get the idea. We're going to do this same technique over and over and over again with more and more complex formulas to get all kinds of cool results. And that's going to happen now. So if you Google parametric equations, you could find this Wikipedia page on parametric equation. And let's scroll way down here. And here's some examples of what you can do with this equation here, where x equals cosine AT minus cosine BT to the j, and y equals sine CT minus sine DT to the k. Let's look at this example where j equals 3 and k equals 4, and ABCD equals 180, 80, 80 to give this kind of a heart-shaped thing. Let's try to duplicate that and see if we can also look at other variations of this same formula. So it takes 6 parameters, j and k, which are the exponents here, and a, b, c, d, which are the multipliers of t. So we need to create 6 parameters and rig it up under that formula. So let's minimize that. We'll create a new project, and obviously a spline formula. Just going to go ahead and change this from 0 to 2 pi for now. And we'll give it 20,000. All right, now I'm not going to change these formulas directly here. Let's go ahead and create the user data and the little rig that we need, and it'll automatically set these to the formulas we want. So go into user data, manage user data. We'll add a group, call that parameters. And then under parameters, we'll add data. We need j and k. And I'm not going to give that any limits. And we want it to be a float, a real number. And I can copy that for k. Rename that to k. I'll copy. Now we need, well, let's see, j. Let's give it the values. J was 3, I believe, and k was 4. So we'll default these. Okay, I'm going to click on it. It's 4. And now we need A, B, C, and D. So we have A, B, C, and D. And let's default these to the values that made that heart-shaped thing. So A, we want the default to be 1, B, 80, C, 80, and D, 80. And we hit OK. Okay, so there's 3, 4, 180, 80, 80. So those are our parameters. Now we need to build the equations using Xpresso to plug in here. So we'll go ahead and right-click on Formula and add a programming tag. Oop, not a Python tag. Delete that. Add an Xpresso tag. And we'll drag formula in here twice. For this one, we want the outputs of the user data. So we have J. Let's stretch this open. Whoops. J. K. A. Unfortunately, you have to click on each one separately. Is there anybody knows of a way you can grab all these parameters at once? Let me know. B, C, and D. And we already know we're going to want the XT and YT on this side. And in between, we want our Python Xpresso node. Now, these two are already real numbers, so I can leave them. I'll just rename them. So we need 6 of those. So we'll rename this one J. Give them the same names. Rename this one K. And then we need 4 more real numbers. I mean floats. 1, 2, 3, 4. And rename these A, B, C, and D. C and D. And over here we need to delete this port. And add 2 strings. 1, 2. And we'll rename these XT and YT. Whoops, I renamed that by mistake. Yeah, it doesn't matter. XT and YT. My menus seem to be flaking out, probably because I'm recording and it's eating up all my graphics memory or something. Delete that so it's just named Python. Okay. Now we need to open up the Python editor and remember that if you have an output, you've got to declare it global. Now, I've already copied the formulas we need here. I'm just going to paste them in here as a reference. So xt is going to equal to that as a string, and then we need to replace the variables. So I can get rid of A, put 2 quotes, 2 plus signs, and then put string of A, if you remember that. I can copy everything from, I have to say A times T, code times B times T. Now you can't just say to the power of J like that. The syntax for Python is you have to put 2 values in a function. So we'll put pow for power. The first term is that. And the second term is separated by a semicolon, and then we close parenthesis. So that's the correct syntax. So we will change this B, whoops, go back over here, copy this from the quote to the quote, paste it over the B. I don't know what I hit there. paste it over the B. What? Let's start over again. Control C here. Control V here. Oh, that's better. Change that to a B. And for the J, Control V, change that to a J. Now I pretty much could copy this and change a few things for Y. So we want this to be YT. We want this to be D. It's not cosine, it's sine. And this is C. A, B, C, and D. And this is also sine. And instead of J, we have K. All right, I think that should do it. So we close that. I'm going to link up these connectors. I wish there was an easier way to do this one too. I'll move this closer. All right, so get all these linked up, and then xt goes over to xt, yt goes over to yt, and we should be good to go. Well, we don't see it. Is that it there? Oh, there it is. Oh, I think, yeah, it's because we're dealing with sines and cosines again. Let me see if the formulas look right. Yeah, they do. But what we have to do is multiply each of those by 100. So we'll go back in here, click on the Python node, open the Python editor, and just add a multiply times 100 at the end. We'll just hardwire that in. That's fine. And, okay, what did just happen here? We've got cosine times 100. Oh, I probably have to wrap the whole thing into a parentheses. We're multiplying the whole thing by 100. So I'm wrapping this whole thing like this. Parenthesis here and a parenthesis here. Okay. And there we are. So that's pretty cool. Now, one thing about this is flat, which is nice, you know. Let's play around with a couple of different values. Let's say instead of 80 and the C parameter, we'll, yeah, 79, 78. We get all kinds of cool little patterns here. I just want to give this some depth. So in the Z, one way that we can give this depth and have it kind of wrap back on itself is to use a sine or a cosine function in the Z parameter. So let's just say the sine of t, and we know t goes all the way up to 2 pi, so that's going to give us a range from 0 to 1 to -1 back to 1, but we have to multiply that by 100. Okay, now we get this cool 3D shape. Let's look at that in 4 views. Let's change this one back to 80. So you can see that the front view has the hearts, but it's actually this cool shape. Now, since this is a spline, you could well, let's do that. So on this formula, we can, let's put it in a sweep. Hold down Alt so it's under the sweep, and then let's create a circle. Let's create an end side. Let's make this really tiny. Let's say 2. Put that in here. So how about that, huh? Isn't that cool? Change the size of this end side so it fills it in. That is some weird geometry. All right, I'm going to pull it out of that sweep and just play around with some more parameters. So all of these are 80. I'm curious. I'm going to select B, hold down Control, select C, hold down Control, select D. So B, C, and D are all selected. I'm going to hold down Control and change any one of these, and they'll all change. Interesting. It's still the same shape. It just has fewer loops. Let's start with 0. It's just a circle. I'm just clicking up arrow 1 at a time. So it only starts to look like hearts when we get to 4. And then the higher we go, the more hearts there are. And you can go up really high. Now you see what happens when I get up to 400? We don't have enough samples to make that round. We could hit cubic interpolation to round that off, or add another 0, so we're at 200,000. Let's go back to our 4 views. Yeah, that's pretty dense. Now let me just see what happens if I just change the middle one here. Anyways, this is where I started to play around with animating these numbers. There are literally hundreds of different patterns you can make with this one interesting. So with this one equation, with these parameters, I wouldn't know if it's, wouldn't say infinite, but there is an awful lot of different patterns you can make with this. So let's just try one more with a different set of numbers here from that web page. Let's see. Let's try, let's see. Close this one. What's another interesting looking one? All right, what about this one? 81, 81. So it's 3, 4, 4, 80, 1, 80, 1. That doesn't look like what we were looking at. Let me see. Did I get that right? Oh, it's 3 and 3, not 3 and 4. So that's interesting. The the K parameter, if we make it 3, we have 4 of these bulbs. If we make it 4, we have 3. Oh, so if it's an odd number, we get 4. If it's an even number, we get 4. I mean 2. So that's kind of a neat shape. Let's change this 80. Well, all right, I won't waste any more time on this, but you get the idea that we took an equation that we found on Wikipedia and parameterized it. We put it into a little rig where we could play around with the parameters. So we can explore different shapes here, or we can animate those parameters. So the next thing I'll do is I'll duplicate the video that I was showing at the beginning, which is, let's see, I'll pull it up again. Well, let's see, I think I still have that open. If I go back to right here, this one. And what I did is I cloned some balls onto it, and that's all it is, with a couple parameters. Now this one, you can see I've got, it's a much more complicated looking thing, but we'll build this from scratch, all the way up to rendering it. So we'll do that next. Oh, one last point here. Let's say you really like this. Let me go back to what we had just created here. Let's say you really like this. You could actually save this. Well, let's see. I'll go back and change this all to default. I'm going to click on J, Shift, click on D, so they're all selected. Right click, reset to default. So now we're back to our heart shape. Let's say I want to just rename this Formula 3D Heart. Well, you get the idea. All right, 3D Heart. And I want to save that. Well, you can open up your content browser and under presets, you could say File, New Preset Library. Let's call it Formulas. And then just let me pull this out here. I'm going to go into, I'm going to undock this for a second. And we're just going to drag this formula and drop it in there. So now, if you ever want to use that again, you can create a new project, double click on it, and you can start with that. You could eventually build up a whole library of different formulas and name them and reuse them. In fact, I've done that already. And here's what mine look like. I called mine Spline formulas. So I have all of these already created that I can reuse. I'll show you some of these later at the end of this tutorial. So what we're going to do next is create another new project. And this time, well, this step is always the same. Maybe instead of going through and having you watch me duplicate all the same steps we've already done with a different formula, I will pause the video here and start it up again once I've done that. Okay, so I've gone ahead and created some user data. Let me show it to you. So I have 5 parameters, B, S, H, ZM, and TM. So what this is I'm creating the formula for a spirograph, but I'm adding some Z parameters to make it a 3D spirograph. So B is the big circle, S is the small one, H is the distance from the center of the small gear to the hole where you put the pencil in. And then ZM and TM have to do with making it 3D. So for B, I've set some limits, 0 to 1,000 with a 200 default. It's a real number. For S, I gave it a minimum of minus 1,000, max of 1,000 with a default of 100. For S, same as B. For ZM, I defaulted it to 0, but it has a step of 0.1, and same for TM. So that's it. Those are my 5 parameters. And then inside of my Python, hopefully you remember how to do all this, right? I exposed these user parameters on the formula. I've created some new ones here on the Python. And this time I created 3 strings because I was going to set the Z with a formula. So here is the formula. You could see by the comment, this is the formula. It's much more complex, even though it only has a few variables. But again, it's a spirograph thing. So B and S are big and small gears, and H is the distance from the middle of the small gear to where you stick the pen or pencil. And then for the Z parameter, I just did what I did before, the sine of t times some number. But this time I gave the ability to multiply the t or multiply the z. I mean the overall number. So all I have left to do here is to connect these. So I will here. Xt goes to xt, yt goes to yt, and zt goes to zt. Now, so far we don't see much here, and that's because, well, let's look at it in 4 views. Well, my range only goes from -1 to 1. We probably need a much bigger range. I've found out from playing around with spirograph formulas that you need an awful lot of loops to make it work. By the way, I have a separate tutorial on it. My very first tutorial, I believe, was how to do a spirograph. So if you want to check my Pappy's Tutorials YouTube channel, you can check out that. You'll find out a lot more about this particular shape and how it was done. So let's make the Tmin 0 and the Tmax. I'm just going to make it really big, like 240 times pi, because we're going to have a lot of loops. You need 1 pi, 2 pi's for every loop, essentially. All right, so now we see something a little more interesting, but we still only have 20 samples. We got to pump that way up. So I'm going to go to 200,000. Okay. So here is, let me change this Z. Let me go to my parameters here. Change this to 0. Change this to 0. Yeah, now we've got just a flat spirography thing. And you can see if I change the radius of the small circle, we get different patterns. Right now, the radius is negative. If I go positive, we are on the outside of the circle. Let's see, I got 120. Let me just make this 10. Interesting. Let's make it 50. And let's make the whole radius the same distance, 50. Okay, so this looks like it's rolling on the inside. I'm going to click on S, click on H, and hold down Control and change them simultaneously. So you can see that that's the path of a circle rolling on the inside of a circle makes. If I make this -16, now we're on the outside of the circle. Anyways, there's a lot of ways you could play around with this, and the patterns are beautiful. I'm sure you've seen spirograph. But now when we add a Z dimension, it gets more interesting. So we'll make ZM1. I'm going to show the formula also. So we've got the sine of t times 0. That's, 0 sine of t times 0.1. Yeah, let me make this one 1. So it's the sine of 1 all the time. And then I can change this to really deep. Now what happens if I make the sine 2? Let's look here, see if I can get a better view of it. It looks like it's creating concentric barrels, deeper and deeper. Let's try some other numbers here. Wow, that's a lot of loops. Let's make this much deeper. I've got 0 there. Oh, I've changed this to 0. That's got to be 1. All right, now we have this cool shape. That's starting to look familiar from that video I was showing you. So now let me change the TM. I'll up it by 1 at a time. See, there's 2 loops, now 3, now 4, now 5. So that's what that does. So that's kind of cool. So I'm going to leave it at 2, and then we can animate some of these other things. So let's see what some of these other parameters do. So S is the size of the small circle. Let's see if I make that 97, 96, 95. Let's go the other way. 98, 99. All right, well, let's start there. So we'll set a keyframe there at 0. Make sure I'm looking at the whole timeline. And then we'll go to frames, say 120. And we'll make this minus 97. Whoops. So I want it to go from minus 99, and then every 2 seconds, subtract 2 from that size. So I'll set a keyframe there. Let's look at the timeline. What that H is doing there. So here we have the S. Now I don't want that radius to gradually change. That would be crazy because it will give us insane amount of loops. So what I'll do is I'll select this whole thing and change that to a step function. And then on S, I will make that offset repeat. And then what that does, if I shrink this down, you'll see it, is that over the timeline, it continues to change that, but by 2 each time. So that's that one. So let's see, we'll go back to the formula. Now, what about H? What does that do? Oh, that's the. Now let's range that. Let's see. Let's say we'll start it right about there. 199. Go back to frame 0. Set a keyframe there. Whoops. And then on frame 120, let's make this a lot smaller. Actually go down and loop the other way. Say minus, let's say minus 222. Okay, that's good. Set a keyframe there. Go back to the timeline. Look at H. Fit it to the screen. And what I want that one to do is oscillate. So I want it to go from 200, whatever this is, from 199 down to minus 222, then back up to 199 and oscillate. So again, if I click on the name of the parameter here, I can go over here in this dialog and change this to oscillate. Now that's just going to go back and forth. Let's see what that's doing so far. So yeah, it's oscillating nicely, and each time it reaches 2 seconds, it changes the number of loops. Okay, so what's next? Go back to formula. Well, what about this function, this zoom function here? So how about, I'll go back to 0. All right, how about if we start at 0, we'll make it 60. And then let's say at 60 seconds, we'll make it 300. And let's see how that works. I don't like that. Oh, did I even change it? What did I do? It's 60. We'll make it minus 300. Okay, set a keyframe. Yeah, now let's look at the timeline. ZM, fit it into the window. We got to make that one oscillate too. So click on ZM, make that oscillate. Go back here to the view, and let's see how that looks. Well, that's not too bad. So now what I'm going to do next is I'm going to clone some spheres onto that. So we're going to add a sphere. Make it really small, say 10. Yeah, 10 looks good. Maybe a little bigger. We'll see how it looks. And then I'm going to clone that sphere. And set the cloner to object and drag the formula into the object. And now the count is only 10. Let's make that some multiple of 360 and space them evenly. That may be too many. Let's say 180. Okay. Let's see what that looks like. Okay, that's pretty cool. So now what I'll do is maybe I could rotate the whole thing. So under formula coordinates, let's zero that out. Let's see. So let's add a camera and zero this camera out. Let's see where it is. So it's looking straight in at it right now. So I'll back out from there. Okay. And let's see what that looks like. Not bad. So what I'll do on the formula is to rotate this from 0 at frame 0 to 360 at frame 360. So now since that's the whole timeline, I don't have to do anything. And so now it's slowly spinning and turning, and I think I'm not sure I like the ZM parameter. Go back to formula, parameters. Let's look at this timeline. Start at 60. Let's try, say, minus 500. I can change that here. Take another look at that. Maybe I'll leave that a positive. So I'll make it 500. So it's going to go from 60 to 500. And maybe I want it to go from 0 to 500. All right, that's the more of the look I'm looking for. I kind of like it to change right when it's right at that angle. So we're going to start with 90. So could do that here in the timeline. So on the rotation, I'll start with 90. Actually, I'll show you a cool thing. You can select all keyframes. And then if you want the key value to be greater by 90, you could say X, which means whatever value it is now, plus 90. And the whole thing moves up 90. So now let's see. If we start at the beginning, yeah, that's how we start. And then it stretches out, slowly spins. So now let's give it some color. So with the cloner, what we can do is add a random effector. Why am I not seeing that? There it is. And we'll take the parameter and not use position, but instead use color, effector color. Make that sphere a little bit bigger. And that's kind of too intense of a color. So what I'm going to do is go back to cloner and make that blending mode. Actually, I want the random effector. Make the blending mode add. That lightens up those colors a little bit. And then one thing cool about splines is if you want to render them without adding other geometry, you can create a new hair material. And let's change two things. First, the color. We'll make it all one color. Some kind of a bluish, maybe a little bit lighter, like that. And we'll change the thickness so that it's the same thickness all across. Let's make it 0.3. And then add that to the formula. And let's see how that renders. Yeah, that looks pretty cool. Let's wait till we get a nice dense one. Yeah, like that one. Let's see how that looks. Yeah, so that's what I did. So the rest is just rendering it. So next what I'll do is I'll show you some other things that I've done with different formulas, and that will wrap it up. So let me show you some of the other things I've done with this formula and other formulas. So here's one that uses a couple of them. That rotating spiral in the back. Actually, it's not rotating. It actually is increasing. One of the parameters is animated, and then that scribbly thing in the middle is just another animated parameter of I believe the first complicated formula we were playing with that came from Wikipedia. Here's one I did that is a coil that fits a sphere, and it's just a little art project. Here's another one that uses a formula that looks kind of random, but it really isn't. It's just one parameter that's animated. Now, other than doing art projects, there are curves beyond Wikipedia that, like for example, can do things like an airfoil. So here's the X and the Y somewhere down here. So I've started to implement this. I'm slightly off right now. It's kind of complicated, but I'll show you what I've got right now. The airfoil that I created actually has leading edges and trailing edges and edge tops and so on. So each one of these is a different formula, and I tie them all together with this control null. And well, you don't have to know anything about airfoils, but that's a very precise mathematical shape. And for example, I can change the camber, I can change the length of the cord and the position. You can see it kind of rolls. That's the position of the maximum camber. So it can be used for very practical things other than artistic. And then I had some fun with, let's see, with this one here. I used a formula I got from Wikipedia, which has cosine times a cosine times a sine minus a sine times a sine, and playing around with different formulas, and then I swept a circle onto it to make this, and you could see that well, if I change some of these parameters, so I was just stepping through the different parameters, seeing what shapes I got, and then came up with a design that reminded me of some kind of warrior collar or something. So it's an interesting shape. Okay, and finally, I've shown you the various formulas I've already saved. These are saved with their parameters, all the everything that you can use to play around with them, and I've saved them all into a separate preset library. So it actually saves a file called spline formulas.l4d, I believe, and that file can be shared with others. So let me show you some of those. Let's see. So here I've added a bunch of them to a project here. And right now we're looking at formula cone. Well, that's what I named it. So these are formulas I all found by looking up on the web somewhere. So if you Google formulas, you can find all kinds of stuff. Parametric formulas are better because they usually break it down by X, Y, Z. And so this one here, I can change the radius, I can change the height, I can change the number of loops, and I can give it a wave, which is kind of cool. That one I just added for the fun of it. And here it goes from minus 2 pi to 0. Let's say it goes from minus 2 pi up to 2 pi. It'll create that. And let's say I zero out this one. Now it's kind of a tornado-y thing, but it is a spiral. Kind of fun to play with. So let's look at another one. Here's something called a Rodania. This one has 4 parameters. And if I change, let's see, if I change the height, I got to click on it. No, this one has 3 parameters, a size and an MXMY. Now, if I change either of these separately, it gives me a really bizarre pattern. But if I make them the same, So I'm going to click on that one, control click on this one, and then as I change either one, the values will stay the same. So that's 15 loops. Now what's interesting is when the MX or MY are together, if they're even, you get double the number of petals. If they're odd, you get the exact number. So let's see, if I go down to 1, I only get 1. 2, I get 4. 3, I get 3. 4, I get 8, and so on. So that one's kind of interesting. So, all right, how about sine wave on a cylinder? So you can pick the radius of the cylinder, the frequency of the wave, and the wave height. Let's drag this over here, and let's actually add a real cylinder, and I'll show you how it fits perfectly. So by default, the radius on a cylinder is 50. So let's go back to sine wave on a cylinder, change this to 50, and it fits perfectly. And so let's say we wanted to add a extrude to that, or extrude that, and we'll extrude it downwards in the Y direction. And let's give it a different color. So that's kind of cool. Change the frequency, the wave height, move it up or down. All right, I'll undo all that. And how about sine wave on a sphere? I'll get rid of the cylinder, add a sphere. I love this one. Add some more to make that look nice and smooth. So it perfectly fits a sphere. So again, you can change the radius, but let's leave it at the default, and change the frequency and change the wave height. And of course you can animate any of these. So then we've got sine wave on a hyperboloid, which is similar to sine wave. I'll change this to where am I? Sine wave on a hyperboloid. Change the radius to, whoops, let's reset all this to default. See, that also has an inside radius of 200. But what a hyperboloid does is it bends outwards instead of following a sphere. I mean, these formulas are just free for the taking. You just have to look for them, add a few parameters, and then make a little library. And a lot of these things may become useful for art purposes. Or all right, now this one I love, sphere helix. Let's change the radius to 200. I guess it's 100. And then we've got this number of loops. It's a perfect helix that fits a sphere. I love it. So yeah, so what I did in that animation is I just animated the number of loops. I love the way this renders when you, let's see, I'll hide the sphere. So there's no sphere behind that. Let's see, will this render? No, it doesn't render, and that's because I need to add the hair renderer as part of the standard render. So that's pretty, I think. So that's the way it would render. But let's see, make it way less loops. How about there? It's just a cool thing, I think. Again, I don't know what practical use it has, but for art purposes, I think it's a lot of fun. And now we've got a formula for a torus. Now, right now, this one shows very few loops, but let's see, I'll keep adding loops, and you'll start to see that it's a spiral on a helix, on a torus, and I have the default set so that it exactly fits the standard torus. You can change the pipe radius. That's probably a cool effect. All right, so that's a torus. And then we've got a wavy spiral. This one, I guess I made it pretty big. Select the wavy spiral, fit. Okay, there it is. It doesn't look too wavy because one of these parameters, I guess it's the YA. If I change this, it becomes wavy. Again, it's just a pretty looking thing. I'm not sure what practical purpose it has, but you know, you could sweep things along it and get this cool shape. You could have something follow it with a line to spline. So those are some of the things that I've put together, and I think what I'll do is for each one of these, like let me show you this wavy spiral. If I go into the Python editor, it's this X, Y, and Z. And there's a different number of parameters on each one. So wavy spiral has 6 parameters. Torus has 3. Sphere helix has 2. Maybe I can document some of this and put it into the description of this video. And then I will look into whether I want to actually share all of these things. I guess I could with you. So I could make the Spline formulas L4D file available for download someplace. I probably won't do that right when I post this video, but a little later on, once I figure it out, I'll add it to a pinned comment at the top. Anyways, that concludes this tutorial. It's gone really long. I hope I didn't lose too many of you. If you stuck with me to this point, thank you very much. I appreciate all the subscribers I have now. I just hit 150 not too long ago. And I enjoy doing this. I'm a retired engineer and software developer, and I just got into Cinema 4D just to keep my brain alive and have some fun. I enjoyed a lot, and I hope I've provided some good information for you. And with that, I'll say goodbye and see you next time.